Hello everyone, welcome back to ANR Academy. This is Nepal Reddy sir. Today we are going to discuss the proof of sine of theta plus alpha. We know that sine theta plus alpha equal to sine theta cos alpha plus cos theta sin alpha. To prove this result, first we will discuss about sine angle and cosine angle on a unit circle. After discussing this concept, then we go for the proof of sine of theta plus alpha. Here there is a unit circle, center at origin, and assume that here P be any point on the circle. Then the length of the line segment OP, that is radius of the circle, since that is unit circle, radius equal to 1. And here assume that theta is angle made by the line segment OP with the positive direction of x-axis in the counterclockwise sense. And now here, if you drop a perpendicular from point P to x-axis, then this horizontal component, that is cos theta, and vertical component is sin theta. You know this. Coordinates of P cos theta comma sin theta we can write due to unit circle. Using this concept, let us prove sine of theta plus alpha result. See, I am going to select a right angle triangle whose hypotenuse is of length 1 unit. Suppose that there is a right angle triangle, its hypotenuse is of length 1 unit, here it is of 90 degrees. Assume that the triangle is here having the vertices capital A, capital B, capital C. Just now we discussed about cosine angles and sine angle on a unit circle. In a right angle triangle, base is cos theta, height is sin theta. So here in this right angle triangle, if suppose here if it is angle theta, then base can be written as horizontal component as cos theta, this is cosine angle, and perpendicular is sine angle. Next, what I am doing, observe. Suppose if you drop a perpendicular from the point B to this line, there exists another right angle triangle here. Assume that this is vertex D. Here in the previous right angle triangle, length of hypotenuse is 1 unit, so that base 1 into cos theta, height 1 into sin theta. In case the hypotenuse is of length, suppose 2 units, then here you have to write 2 cos theta, here 2 sin theta. Horizontal component r cos theta actually, depending upon the radius r. Vertical component r sin theta. Here, since length of hypotenuse is 1 unit, so that cos theta sin theta are horizontal and vertical components. Now let us see in the right angle triangle ADB. Now hypotenuse is of length cos theta. So horizontal component written as length of hypotenuse multiplied by, here suppose that it is of angle alpha. Whenever hypotenuse is of length 1 unit, 1 cos theta, 1 sin theta are the components here. Now hypotenuse is of length cos theta, so that cos theta into cos alpha horizontal component, cos theta into sin alpha is vertical component, or cos theta or sin theta model. Here angle is alpha and radius r is cos theta, so that r value cos theta, next cosine angle, r sin angle. Now let us drop a perpendicular from the point C to AD. From C to AD, I am going to drop a perpendicular. Assume that this is some P, and also drop a perpendicular from B to CP here. Assume that this is the point Q. Yes, and observe QB and AD, these two lines are parallel. Therefore, here is alpha. Why? Because these two are alternate angles. Next, if it is of alpha, then automatically this is 90 minus alpha. Why? Because the entire angle is 90 degrees. And next, since it is of 90 degrees, here the angle is alpha again. In a right angle triangle, sum of interior angles in any triangle, here it is right angle, sum of internal angles is 180 degrees. 90, 90, 180 minus alpha plus alpha gets cancelled, so sum of interior angles we get 180 degrees. Now let us observe triangle ACP. Using triangle ACP, I am going to write horizontal and vertical components. Yes, from triangle ACP, here it is theta plus alpha, and this one horizontal component, C to P vertical component. C to P, that is clearly vertical component. A to P, this is horizontal component. We know that horizontal component, that is r cos theta. So here radius 1 unit, therefore 1 into angle theta plus alpha, so 1 into cos of theta plus alpha. Horizontal component is AP, horizontal component cos of theta plus alpha. Here from the triangle ACP or APC, AC is hypotenuse, that is radius 1 unit, angle here it is theta plus alpha, so that horizontal component cos theta plus alpha. Next, vertical component C to P, that is radius 1 unit, and vertical component denoted by sine angle, sine of theta plus alpha. Here our aim is to find sine of theta plus alpha. So sine of theta plus alpha is nothing but C to P distance, Observe the figure. C to P distance, that can be written as distance from C to Q and then Q to P. Now observe the distance C to Q now. See the triangle BQC, this one, BQC triangle, and for which this is opposite to alpha you have QB, and this is adjacent, and this is hypotenuse, right? So hypotenuse is clearly radius, and here it is angle. So from this right angle triangle, base is horizontal, right? Horizontal line. So it is horizontal component CQ. Horizontal component radius into cosine angle, that is sine theta into cosine angle. In this triangle, radius sine theta, hypotenuse length R, and horizontal component cos alpha. Next, this is perpendicular. Perpendicular is in a right angle triangle, perpendicular height, that is vertical component sin theta, and this is base, horizontal component, this is cos theta. So here in this right angle triangle, this is cosine angle cos alpha along with radius sin theta. So sin theta into cos alpha, and this one, but we need Q to P next. Q to P already you have here. Q to P is same as B to D, and you have here it is cos theta into sin alpha. So that I can write here it is cos theta into sin alpha. So sin of theta plus alpha, finally sin theta cos alpha, cos theta sin alpha, and hence the result proved. Sin of theta plus alpha is this one. Just replace alpha by minus alpha, then you will get formula for sin of theta minus alpha, that is sin A. Alpha replaced by minus alpha means cos of minus alpha now, again that is cos alpha. Next plus cos theta as it is. Suppose here alpha replaced by minus alpha, sin of minus theta minus sin theta. So using that formula you will get minus sin alpha, and hence sin of theta minus alpha become sin theta cos alpha minus cos theta sin alpha. This is the proof for sin theta plus alpha and sin theta minus alpha. I hope you have understood everything. The students, those who are watching my videos, please subscribe ANR Academy channel and don't forget to comment on comment box. Thank you so much.